Welcome to this video in the series on exploring Cimatron for mold design. In this video, we will be discussing the setup table feature of Cimatron. This includes the different controls available to you, ways of sizing the mold base, and sizing components. This totally customizable feature works well when creating a custom mold assembly, by allowing the user to control many aspects of the design. The single table format provides us with access to control many parameters of the mold base creation and component sizing, using a variety of methods. We are going to start off with our parting surface part where we left off in the last video, with our core locks added and our parting surface part, so we recommend you watch the previous video in this series first. We have our split part and core locks in position. Here is the core half. You can see the core block and the plates. We can see the corner locks are sized to the block already. This is because the corner locks are featured in the setup table. We open the setup table from this menu item. There are sections that control the top view, containing things like length, width, as well as other parameters. The corner locks have their own section of the setup table. This data was brought in as part of the component and automatically populates the setup table. Here we can control things like the height, as well as the length, width, and angle of our corner locks. We have other sections like cavity, core side, and ejector to control things like the plate thicknesses, rail widths, and ejector stroke. We can also control our core and cavity overlap to ensure we have enough material to machine. Along with these major assemblies, we can create components and other sub-assemblies to work with the setup table. Within these sections, we get a dialog box detailing the parameters we can change. For example, for the top view, we can change the length and the width, as well as some plate overhang parameters. Going to the cavity side, there are controls for the plate thicknesses, and our overlap for Z0, where we would like the blocks. Back in the top view, we can click on the length to see it is driven by a formula. This formula contains parameters from the part bounding box and delta values. While we are here, let's look at other ways to add parameters. There is value, which is a number. From and to, being a defined range. And from list, which is a list of sizes from a catalog part such as the core block. We will stick with the formula. Now I will open up the formula to see the relations. These contain parameters that we are getting from the Mold Layout tab, down here. Once we open that, we now see the part boundaries. These boundaries are set whenever the work part is introduced into the mold assembly. Even if multiple work parts are brought in, the system will set one boundary for all of them. Here we can see the bounding data area has been filled in and cannot be edited. We can, however, change these delta values. They control the amount of steel we would like to see around, above and below the part. If we make some changes and accept them, we can see the mold base change. This is possible because the blocks and plates have been created using dimensions driven by the values in this table, including the corner locks. Let's take a closer look at the mold. We see there is not enough core steel to accommodate the part. Inside the setup table is a parameter to adjust the placement of the core block. Here it is called core overlap. By changing the Z height here, I can adjust the placement of my core block, which will update the rest of the assembly. Having this control through the setup table enables you to move multiple components in a single operation, and not have to worry about adjusting the placement of many items. After applying the change, I can see there is now enough core steel to machine. We will look at the cavity and change the cavity overlap as well. These are simple values working from Z0. There is now enough steel in the core and cavity to cut the blocks with the parting surfaces. Several other things can be controlled and adjusted using the setup table. For example, we can change the width and height of rails, thicknesses of the plates, and the length of screws. Also notice the other components such as screws, guide pins, and pillar supports automatically make adjustments. By using this approach, we can dramatically cut down the design time required. Thank you for reviewing this presentation, and look out for other videos in this series.